Yeah, hi everyone. Welcome to today's NEAR Educate workshop. Really excited to have Lewis with us from the Octopus team. So yeah, I won't take up too much more time. So without further ado, Lewis, go ahead and you can kick things off.
Thank you. Thank you. Thanks to Encode Club and the NEAR EDU for inviting me. My session will cover Octopus 2.0. Let me share my screen.
Awesome,
Okay,
that's good.
cool. Yeah. So, so the topic it explains itself quite well. Octopus 2.0, our next step will composed with two major new innovation, NEAR Restaking and adaptive IBC. For those who don't know Octopus Network, I will give a brief introduction. So we are working in NEAR ecosystem. NEAR is a Web3 infrastructure to embrace as much as possible Web3 developer. It provide quite comprehensive infrastructure, tooling, etc. So the core is a sharding blockchain, and we have Aurora for EVM developer, Calimera for enterprise use case, Pagoda for tooling, and other utilities such as Indexer, RPC service, and blockchain explorer. Machine for decentralized storage, and overall, NEAR is working on blockchain operating system to provide a streamlined user experience to serve the, let's say, the upcoming 1 billion Web3 user, and there is great developer tools to help developer to build this great user experience. And the last but not least, Octopus Network, our project, is a multi-chain network built around NEAR protocol. We try to, let's say, mimic the topology of Cosmos ecosystem. That's a lot of application-specific blockchain built around a hub and can interact with each other. So in our paradigm, NEAR blockchain will be the hub, and there, I wish we wish that we can onboard a lot of application-specific blockchain. We call them app chain to NEAR Eco, and we provide shared security, interoperability, utility, and community support to those app chain. Octopus Network mainnet has been around for almost 2 years, and now we have 5 app chain running inside our network, and yeah, we do hope that there will be more. And since we have been working on the project for quite a while, I think it's the time to push our offering to another level. So we have the plan called Octopus 2.0. Uh, the first part of Octopus 2.0 is about NEAR restaking. So restaking is a new concept or new primitive invented by Eigenlayer, uh, a researcher start this eigenlayer from NEAR research community, and we find this new concept very interesting and also powerful. So we like to embrace it. And so we are working on a smart contract called restaking base. Once it deployed to NEAR blockchain, NEAR holder can stake their NEAR asset to restaking base smart contract rather than stake their asset to the layer one staking pool directly. So by doing that, but they still NEAR holder need to specify which validator they would like to delegate it to, and by doing that, they still get 100% layer one staking rewards. And but now they have an asset controlled by restaking base. They have the option to restake to app chains. And in this diagram, we show the whole process. The first step is about binding staking to Octopus app chain, and the app chain will accept or reject this bonding. And if the bonding success, it means NEAR holder and the app chain make agreement about security providing. So the NEAR holder need to run a validator node for the app chain, and then they can get app chain rewards. In most cases, it will be in app chain native token, but it could be other token such as NEAR OCT stablecoin coin. It's totally up to the app chain community to decide how many and which type of token will be distributed to their validator. But more rewards they provide, more staking they will get. So the security level will be determined by the incentive level, and a fraction.
Lewis. Oh, sorry. We
Okay.
just had a couple of questions in the chat. If you don't mind answering them before we move on. Matthias asks, can you compare restaking on Octopus versus Eigenlayer?
Yes. Essentially, it's the same thing. Eigenlayer will do restaking for Ethereum, and Octopus will do restaking for NEAR.
Brilliant. Thank you.
Okay, I will continue. So if as far as so far we all things are good. NEAR holder can reuse their asset and get multiple staking rewards. But if they do some malicious things to the app chain, such as maybe the configuration is not right, maybe their node go offline for quite a long time, or maybe they attacking the app chain in some way, their asset could be slashed by app chain. So they need to so for NEAR holder, if they choose to restaking restake their asset to app chain, they bear the risk to be slashed. Okay, so why restaking? So for NEAR holders, the reason is obvious. They get multiple staking income from the same asset, and it raised the capital efficiency. And for app chain, they get more affordable, more accessible, and more flexible share security. Since in NEAR ecosystem, NEAR asset is the single biggest volume asset that could be utilized as a collector to provide share security. So if we involve NEAR restaking into a share security market, the providing side of this market will be boomed, and then app chain can get very cost efficiency and accessible share security. And for NEAR protocol, it will internalize more value stream, which means the app chain protocol will also contribute or also pay to NEAR validator, and it will increase the staking ratio and also increase the cash flow of NEAR asset. So potentially, it's a driving force to push up the price. And once the staking ratio and the token price go up, the capacity to provide security, economic security, will go up accordingly. So there is a positive feedback loop. And for Octopus network, even if we give most of the restaking rewards to NEAR holder, but hopefully the network effects of this share security market will increase by many times. So for Octopus community, it can still hope to get more protocol income by doing that. So in my point of view, the major general purpose public blockchain will compete on sharing economic security to other decentralized network. And so Ethereum began this restaking from EigenLayer, and I think Octopus and NEAR will be the second, since we have been working on this economic security sharing through the whole life of Octopus network, and the restaking is a apparent way to improve the security sharing efficiency. So we take the practice advance. So we hope that NEAR will be the early adopter of this restaking practice and benefit from providing security to other network, and also internalize value stream from them. And if you are developer working on, let's say, middleware network or bridge or Oracle that's dedicated to serve NEAR ecosystem, I think it's a time to think about utilize restaking security since let's say all the middle all the Web3 middleware should be decentralized, since the decentralized application will rely on your middleware, and they would like to rely on a fully decentralized service. So if for any middleware network or even some infrastructure such as RPC gateway or indexer, the decentralization should be always on your consideration, and restaking can bring you network very cost-effective security, and also it will build some strong economic bind between your middleware and the NEAR protocol itself. So it will be a win-win situation. And so for Octopus, we built restaking base.
Lewis, sorry, before we jump on to the next topic, we just had a question from Matthias. It says, as Octopus is an innovator at its core, do you have any insights into how staking/restaking model could be extended to use stablecoins such as USDC, specifically for app chain security for fintech?
I think staking or restaking is a more infrastructure issue. It will increase or decide the security level of the network, and by doing that, more and more crypto protocol and crypto asset can be securely stored and used on public blockchain. So I think it's not directly connected, but improved staking or restaking can have a positive impact on any decentralized application, including stablecoin and DeFi. Yeah.
Amazing, thank you.
Okay, I will continue. Yeah, well, I think we have talked about restaking, and the next topic, NEAR IBC. Yeah, our team has been working on IBC for a while. So for anyone who do not know IBC, IBC is standing for Inter-Blockchain Communication. It's a set of open protocol invented by Cosmos, but it's an open protocol, so anyone can contribute to the standard and the implementation. And for Octopus Network, we contribute ICS10 interchain standard number 10 to IBC protocol. And also we take grants from Cosmos Ecosystem Foundation, ICF, to implement IBC on Substrate almost 3 years ago. And I think it's the first IBC implementation besides the Cosmos SDK1. And now we are working on NEAR IBC. So the first phase of this implementation will support Octopus app chain, and in the next step is about to connect NEAR blockchain into Cosmos interchain, which composed with about 60 blockchains. And yeah, I do think it will create a lot of composability opportunities for both near near application and also Cosmos chains. And so the next step, we plan to implement IBC on EVM with other open source contributors, and then we can connect near blockchain with EVM public chain. The first one will always be Ethereum itself, but potentially other EVM blockchain. And with this, IBC port, we call it a port since it's a interoperability port for the whole near continent. And with this port, I think we have a lot of potential to connect with other type of blockchain. And
sorry, just a quick question. Sorry, in terms about compatibility, Kezon asked, is this compatible with the Silo Aurora cloud and the general Aurora blockchain?
Not really. We implement NEAR IBC in native native Rust contract. So I think we still like the capability for Aurora smart contract call near native smart contract directly. But correct me if I'm wrong. I'm not an expert on this aspect. So for Aurora smart contract, it cannot utilize this near IBC port directly. But potentially, once we support EVM blockchain, theoretically, we can deploy an other IBC port on Aurora.
Awesome. Thank you so much for that.
Okay. So there are a lot of bridge that can be utilized on near blockchain. So why IBC is special? Why we take so much resource to build this IBC port? Since IBC is an open general purpose layered protocol, and from the past experience, as the open protocol will always defeat a proprietary protocol. And I think most of the DF developer, they do not want to let's say coupled with some proprietary bridge design, and the IBC will be their best choice since it's open, it's not vendor specific, it's a generic cross-chain mechanism, and potentially support many cross-chain primitive such as fungible token transfer, non-fungible token transfer, interchain query, which will enable your smart contract to read state directly from other blockchain, an interchain account, make your protocol control another account, resident on other blockchain. So maybe your protocol can be resident on NEAR, but you may have your trader account on Ethereum, and your let's say your DAO protocol can control this trader account on Ethereum, and maybe to engage this treasury asset into Ethereum DeFi according to the decision from the DAO that's resident on NEAR protocol. So I think in the future, in the, let's say, real multi-chain future, it is not about replicate the same protocol from one chain to another. It's about to distribute different function into different blockchain where this function can be fully optimized. For example, for public blockchain like NEAR, for whatever reason, I think it will not support, let's say, fully privacy computing capability on NEAR layer one, but once some privacy computing blockchains such as Secret Network or others connect with NEAR via IBC, you can allocate a part of your protocol function to this new platform. If you need your protocol have some serious privacy consideration. So
just a quick question, sorry, Lewis.
Go ahead, please.
Of course. What would you say is the major technical blocker for implementation from Octopus to Polkadot, and how can the dev community help making this happen?
Oh, it's a great question. I will talk about the difficulty in example of NEAR and Cosmos, but Polkadot is essentially the same. And yeah, you will see why it's so difficult to build an IBC-based bridge between heterogeneous blockchain. Okay, so why Octopus sit at the best position to expand IBC protocol outside Cosmos and cover many heterogeneous blockchain? Let's look at the picture. It shows the IBC connection between NEAR and the Cosmos. And in each chain, we need IBC Tau is referred to IBC framework, which handle the transportation stuff such as connection, channel, messaging format, serialization and decentralization stuff. And beyond the IBC Tau, there is many IBC application level protocol such as fungible token transfer, NFT transfer, and interchain security, interchain account, interchain query, and more is coming. And underlying the IBC Tau is live client. So live client is here for verify the corresponding blockchain, the peer. So we need Tendermint live client run inside NEAR blockchain to verify the consensus of Cosmos chain and vice versa. So this is the basic design of IBC. It's quite elegant, but the problem is the problem is light client. So you guys know that light client is derived from SPV client. The initial goal of the light client is to let the resource constrained device such as mobile phone or browser to interact with blockchain without fully trusted on some centralized node. It can still do their own validation, but it cannot host an full node to be fully trustless. So Cosmos, when the Cosmos burn, the founders come to the idea that, oh, we can run light client on blockchain. So blockchain A can verify the consensus of blockchain B by running their blockchain B's client on its own environment. So here comes the IBC. But besides Tendermint, for other consensus protocol, some blockchain consensus is not even light client friendly. For example, Monero even do not have a light client implementation. And for other blockchain, there is no, let's say, battle tested light client implementation that can be run on other blockchain. So and also light client verification could be very expensive, such as if we try to run a Tendermint light client on NEAR, it will take, let's say, a few hundred T gas to verify a block header from Cosmos chain like Cosmos Hub with nearly 200 validators. So we need to run to verify about more than 100 ED25519 signature in one transaction. It will exceed the gas limit, and also it's too expensive. So how do we handle this problem? We move the light client off chain, and we call it verification proxy, and replace the on-chain part with a proxy client. And for the other direction, there are also problems since there is no battle-tested NEAR light client in Go language that can be run inside Cosmos chain. So we use the same practice. You may challenge this design that by you just you just sacrifice the trustlessness. Yes, you can say that, but we put this verification proxy on the second blockchain. We call it proxy chain. Providing the proxy chain has had the security level not less than NEAR or Cosmos, the involvement of verification proxies will not downgrade the security level of this whole cross-chain system. and we call it adaptive, and we can do the same trick for many other blockchain since it's will be much more easier to run verification proxy than run light client strictly on destination on the source and destination chain. So we by utilizing this adaptive design, we can expand IBC to many different types of blockchain. And we call it adaptive not only because it can adapt to many blockchain, but it also be adaptive to the technology progress. Let's say if we have got battle tested NEAR live client, we can replace this proxy client with the real with the real live client by the client the IBC connection and client upgrade. And this upgrade will be totally transparent to IBC application. So the application will not need to do anything. They won't notify this underlying verification mechanism has been upgraded, has been improved to a better implementation. And so, and we have the plan to replace this verification proxy with real live client and also ZK consensus proof once it's matured, right? And once if we got practical ZK consensus proof, we can replace the proxy client with a ZK verifier and replace the verification proxy with a ZK prover. It will improve the security level to reduce the trust on verification proxy, but without impact, without interfering the operation of any application who rely on this bridge. So that is why we call it adaptive IBC.
Oh,
okay.
sorry. Oh, sorry.
Yeah,
Go ahead.
please go. Yeah, I have run out of my
Oh,
content,
brilliant.
so yeah, please pour in question.
Brilliant. Yeah, we just had a quick question from Oscar. They ask, what does the function calls from chain to chain would enable?
Oh, yeah, for now, the first step is about fungible token transfer. You can transfer NEAR asset to Cosmos chain and vice versa. And the next step, we will implement interchain account. So you cannot make direct smart contract call between these two blockchain. It's not because it's too complex to do that. It's not secure to do that. You know, cross-chain message could be anything, and for the underlying bridge, it cannot quantify the economic risk of this cross-chain message. So it can be very risky to do that. But we can use interchain account as an let's say replacement or an alternative to this cross-chain community, cross-chain smart contract core. That is a protocol on NEAR, a smart contract on NEAR control an account on Cosmos. So you can send a command to this account in binary format, and this account belong to you. It will submit this command on his blockchain. So essentially, most of the let's say cross-chain message paradigm can be supported from this design, but meantime we eliminate the unpredictable, unqualifiable economic risk by the raw cross-chain communication, cross-chain smart contract core.
Awesome. Thank you, Lewis. Of course, any other questions, please do feel free to write them into the chat. And yeah, definitely, Matthias. Yeah, incredible tech on Octopus's side. Really interesting on my end as well to listen to this. But yeah, hopefully we Encode can share the light on this incredible tech. But of course, if there's any more questions, please do.
Okay, thank you. Oh, I need to see a few words, a few more words about the question about the connection between NEAR and Polkadot. So we have finished substrate IBC, and so once the IBC port is enabled on NEAR mainnet, any substrate-based blockchain, whether it's a solo chain or Polkadot parachain, can be connected with NEAR protocol. And but the problem is still let's say light client, and you know, for substrate IBC, it rely on Beefy light client. Beefy is the crossing gadget invented by Polkadot to facilitate interchain communication, and it's still unknown that when Beefy will be enabled on Polkadot mainnet. So it still need to wait for that to set up a real connection between NEAR and Polkadot. But for any substrate solo chain, they can connect with NEAR IBC port very soon.
Amazing. Thank you. Another question from Matthias. What are the first steps for someone wanting to deep dive into Octopus? Don't say docs, lol.
We're sorry that we're not great document writer, but we do develop a lot of things. I think the best place for developer to know about our work is to visit our GitHub repository. I will post the link into the chat window.
Amazing. Thank you for that. And yeah, as Sheldon said, you can always ask questions to the Twitter account, and Sheldon will help, and we will have lots of reference materials for avid readers. So yes, do keep in touch with the Octopus team on Twitter as well.
Yeah, Sheldon is our ecosystem growth tech lead, and I think he's more famous than me in the ecosystem, and do approach to him for any technical questions.
Awesome. Another question we have is, what would be the #1 app chain you would like to see in Octopus?
Oh, the first one has been decided. We will support a community initiative. Some of the Octopus community activists decide to launch a chain. They call it called Auto Chain, and we found this idea very attractive, and so we, as the core team, we decide to support it, and it will be the first Cosmos SDK-based Octopus app chain, and the plan is to start it in this October, and Octopus Network, Octopus will provide validator incentive for this auto chain. So if you are NEAR validator or delegator, do prepare your NEAR to join, and you will earn substantial OCT token rewards by validate this auto chain. And it will not have any impact on your layer 1 staking rewards. You still the NEAR token will is still ultimately go to your own choose validator, and 100% layer 1 staking rewards will be still used, and then you can restake to auto chain and upcoming other Octopus app chain, and earn multiple rewards.
Amazing. Any other questions of to share with the group? If there's not, I might just jump in and ask a question myself. I know we said no docs, but maybe perhaps you could share some docs for the people who aren't able to come to today's workshop and will watch the recording. I think some of our Educate participants would love to see these resources, if that's possible.
Oh, sure. So yeah, we are definitely want to engage with more NEAR ecosystem project protocol developers, and and I think we should do better, and for this year, finally we can make international travel, and personally I will join NearCon this year in person, not online, and also we found that Encode Club and others are valuable partners, and we will definitely love to engage with you guys in more close ways.
Awesome. Wow, a lot of exciting news on Octopus team side. So no, that's really great that there'll be more engagement, especially for developers. But of course, if you have any more questions, please direct them into the chat. Or as Sheldon said, if you have any questions kind of after the workshop, feel free to ping the Octopus team on Twitter. They'll be more than happy to answer any questions. I'm assuming there are no more questions, but if that is the case, I'll let everyone kind of go on with their evening. morning or afternoon, wherever you are in the world. But again, a massive thank you to the Octopus team, and especially Lewis and Sheldon for joining us today. Definitely, yes, a lot learned in this session, and it's a great time to be learning new things with other people as well. And also thank you to everyone who joined us as well to our NEAR Educate series. It's always so great to see people taking part and asking really great questions. But awesome. So yes, I won't keep you here for too much longer, but of course, again, a massive thank you, Lewis, for today's session, and thank you for answering all the questions our participants have said. But hopefully, yeah, we'll see you guys soon next time. Angela will also be back next week. So this is kind of a goodbye from me as well from the Educate series. But thank you all for joining me for the past couple of days. Awesome. Bye, guys.
Bye. Thank you, guys. See you.